Determine which of the following histograms would have the largest and smallest weighted mean. Well, one thing that's interesting about a weighted mean is that if you're looking at it pictorially, then if you could imagine the place where you could set a fulcrum, is what this is called, which is just a balance point, then the fulcrum, the location of that balance point, is where the weighted mean would be. So for instance, if you have data that is, as we have here, this is bell-shaped, so it's symmetric. So a fulcrum that would make this balance would be right in the center. So that would be my balance point here, and therefore right in the middle of the distribution I would have my weighted mean. Now notice that the scale on these axes are the same, and it also turns out you can even count, but there's the same number of data items in each data set, so all of those sorts of things are similar. Now let's say I put the fulcrum in the same place, so between 3.5 and 4.5. Well, there's a problem. There's a whole lot more weight over here on this side than there is down here on this side. So this thing's going to tip. It's going to fall this direction. So to counteract that, we have to move our fulcrum a little bit higher. So maybe it goes all the way to here. It's not exactly sure, but it is something larger than 3.75. Well, no, that would be at 4, sorry. So it is something larger than 4, okay? Whether it goes all the way to 5.5 or not, that I'm not sure of, but it is something larger than 4. And the same is true down here. If I put the mean at 4, everything would fall this direction. So I need to move my fulcrum lower to counteract that so that I keep it balanced, okay? But now, when we look at the values of these positions, this fulcrum's, let's say it's at 3, so approximately 3. This one's approximately at 5.5, and this one's probably about at 4. So the one that's largest is the first one. So this one has the largest mean. The smallest mean would be this one, because its mean is lower than the rest. And neither would be the one there in the middle. So there's our solutions there.